Hi guys, this is Binyamin Ashraf, founder of Engineers Classroom. As you can see in my screen, this is Mechanical Module 4, in which we will go through the about the ducts materials and their classification, different type of joints and connections, and about the flex duct, application area, advantage and disadvantages. Further, we will see about the materials, what we can use to make the ducts, and the flexible ducts, advantage, disadvantage. So starting from ducts, what is actually duct? It is a medium to carry the conditioned air from the source to destination, which source is AHU, RTU, that can be FCUs, and destination is where you need the treated air, that is your room and the hall area. Okay. So it is the media which can carry conditioned air from source to destination. It is called ducts. Okay. You can see here it is 3D version of the ducts and it is in 2D. You can build in Revit. Further, you will see about the ducts and the ducts materials. So to make the ducts, what we can use is galvanized steel. It may be aluminum, it may be stainless steel, and other material you can use as per client recommendation, that is duct board and plastics. This is the material with what we can use to build a ducts. Okay, you can see the classification of ducts based on application, that is four types. First is supply air duct, which is SAD, which can carry treated air AHU to the space of use. Okay, like if the AHU release the air, it will go into supply duct and it will come to the room through the supply diffuser. And return air, which take air from rooms and return to the AHU for the retreatment. It is called return air duct. It is EAD, exhaust air duct, which is used to exhaust the air from the ventilation area, which may be parking, which may be kitchen and restroom. So it will exhaust the duct, exhaust the air from the ducts. It is called exhaust air duct. And outside air duct is something which take air from outside, provide the HU for the treatment. So it is called outside air duct, which take fresh air from outside and provide to the HU for the treatment of air. We can also classify the duct on the basis of pressure. So it is depend on the application what pressure duct we can use according to the client recommendation, sometime according to the application. So it is a low pressure duct which is having a static pressure less than 3-inch water column, which is 750 pascal. It is called low pressure duct. And when you say the medium pressure duct, it is in the range of 3 to 6-inch water column, a static pressure which is equals to 750 and 1500 pascal. And when we can use high pressure duct, it is the static pressure having the range of 6 to 10-inch water column, which is equals to 1500 to 2500 pascal. It is the classification of duct according to the pressure class. So there are basically three classifications. Further, you can see what is actually static pressure. So amount of pressure measured in inch of water column is called static pressure. It is equal to all the direction. It depend upon independent of velocity. You can see here what is CFM. So it is actually the measurement of air which you will use the treated air in the room. So basically we can use how much CFM requirement of air from the specific duct. So flow rate in the per feet per minute, it is called FPM. So FPM into duct cross section area equals to duct's velocity. Further, you can see a SMACNA pressure chart, which is a body which is responsible for to make the ducts. You can see here when you can use the low pressure duct, it is the 125 pascal, which is the operating pressure of up to half weight gram. Medium pressure, it is having 250 pascal, and the high pressure you can have 500 to 2500 pascal, depend upon the application and the requirement of the recommendation. Okay. Further, you can see the classification based on the shape. So basically there are four type of ducts. First is rectangular duct, can be adapted in any height of restriction, easily shipped and convenient and easy to use. It is less in amount also, and aspect ratio should be 1:4 for to use this duct. Okay. Second is round duct. You can see here this is round duct, round in shape and having high efficiency but cost effective. generally having more cost effective. Okay, maximum air capacity, carrying air capacity and low pressure, because low friction in inside the duct, so we can achieve the highest efficiency from this duct. Easier to insulate and aesthetic. Okay. Second, you can see the round duct is two shape: snap lock ducts and spiral duct. It is called a spiral, which is locking from here in the end of the duct. It is called snap locked. When you put the inside the second duct, that should be locked from a snapping area. Okay, this is called the snap lock duct, and this is spiral duct. You can see here in the screen. Further, this is oval duct, which is oval in shape, obviously in a smaller height requirement for the duct area. Retain most of the advantage of the duct, round duct, and fitting of oval duct are difficult to fabricate or modify in the field. And these have some disadvantage also, which is difficulty in handling and shipping large area, tendency to become more round under pressure, and available in the large aspect ratio. So difficulty in assembling also created here. Okay, you can see here classification based on shape, which is round duct, square duct, rectangular duct. You can see here advantage and disadvantage over the round duct, square duct, and rectangular duct. So lowest friction in the round duct, which is good advantage. Less material required or for fabrication, so it is also advantage. And disadvantage, you can see height required to install round duct is more. So it is requiring more height to install the round duct, and fabrication time is more. Fabrication time is also more in the round duct. And when you can use the square duct, it is having less friction as compared to rectangular duct. This is advantage. Less material used for fabrication, and disadvantage, you can see height required to installation is more as compared to rectangular duct. So this require more height as compared to rectangular duct. You can see here rectangular duct height required to installation is less, so you can install in a less height also. Easy to fabricate at site. This is easy for fabrication at site area. And disadvantage, it can create more friction, so you cannot achieve the full efficiency from this duct. So this is the major disadvantage. You can see here about the duct joint. So this is actually two type: seam and transverse joint. So when you joint vertically, you can see here, so this is transverse joint, and when you see the longitudinal as seam, so this is called seam area. The duct has two area to joint, so you can join from here also. This is longitudinal seam. This is, you can join from here also. This is called transverse joint. So this is the two classification of joint of duct. Here you can see flat S-lock and drive. So this is called transverse joint. You can see here, and the flat S-lock connected through the transverse joint, and drive is to assemble rectangular duct section at transverse joint. So when you see this area is joined by the drive, so this is called drive. Okay, duct joint is, you can see here, this is the class some figure you can consider for the duct joint. So this is all about the diagram only. Transverse connection, ductmate slide onto the raw end to duct section, like you can see in the transverse connection. So connection slide onto the raw into duct section. No additional sealant required over the transverse joint. Completely separate component, a flange that slide over the duct edge. So this is called connections of duct. You can connect through the transverse connection. Here you can use cleat, angle, gasket tape, and duct wall. So this is the duct wall. You can see here, you can connect through two ducts area through the angle and cleats. This is the angle area, and you can connect through the cleat. Okay, and gasket tape is also required for the connection. So this is all about the duct joints. Further, this is called TDC, which stands for transverse duct connector, and TDF, transverse duct flange. So consist of some flange, corner pieces, gaskets, and cleat to complete the joint assembly. It is the material used to join the assemblies, hold the ductwork together, and provide a sealing surface for the gasket used on the medium and high pressure duct rectangular system. So this is all about the joint connection. Duct joint is something like you can when you can join the duct two ducts, because it is not in the full area, it is on the part by part, so you can join it in the site area, so you can use this thing in the site area. This is called flex duct. As you can see in the screen, this is called flex duct. You maybe have seen the mall area and some marriage function hall. This is called flex duct. So this is flexible actually, and this is short in length, generally high pressure drop and acoustic problem. So this is a noise proof. Okay, so this is having no noise, mainly used to connect main duct and terminal unit, that is diffuser and grids. So this is, you can see the flex duct here, the rectangular duct come through this and connected through the flex duct. This is all about a spiral duct. Okay, a spiral, you can see flex also. So ducts, this is having some advantage, which is less expensive than metal one. Installation is less difficult, can be introduced in tight space where conventional metal conduit would not be fit. Having friction loss, this is having disadvantage too, which is friction loss. Strength is an issue, and it is made up of thin malleable material. So this is the disadvantage. So in this session, you have gone through the ducts and application materials of the ducts, different type of ducts and fabricator area, about the duct joint segment and their uses, about the flex ducts application advantage and disadvantage. So thank you so much. We will see the further module 2. Thank you so much to being with the engineers classroom. Have a nice day.